class. In this video, we will talk about the root location theorem in the section 2.3, continuity of a function. We have the theorem root location. This theorem is stated as follows. If the function f is continuous of the closed interval AB and FA times FB less than 0, then we have FC equals 1 for at least one number C in the open interval AB. Okay, this statement have several other ways to express. You can express this statement as there exists one number C in the open interval AB so that FC equals 1. Or you can also express as the equation fx equals 0 has at least one root. Yes, has at least one root in the open interval AB. Okay. Now we will use this root location theorem to prove that some equation has at least one function at some interval. We consider the example. Show that the given equation has at least one solution on the indicated interval A the cubic root of x equals x squared plus 2x minus 1 on the open interval 0, 1. Our task here is to prove that this function has at least one solution, one root, one solution, okay, one root on the open interval 0, 1 by using the root location theorem. Again, we read the statement of the root location theorem. If the function f is continuous on the closed interval AB and FA times FB less than 0, then the equation fx equals 0 has at least one root in AB. And now, what we want to prove here, we want to prove that this equation has at least one root in the open interval AB. So compare with this statement, we can see that 0, 1 here is the open interval AB, and our function here is our equation here is the equation fx equals 1 in the theorem. So compare that to use a theorem to prove what we want. to do what we want, we must change the form of this equation into the form fx equals 0. Of course, that's not difficult for us. So, solution. First, we change the equation into the form fx equals 0. It's equivalent to the cubic root of x minus x squared minus 2x plus 1 equals 0, and we call this expression the fx. Yes, let fx equals the cubic root of x minus x squared minus 2x plus 1. And now to have that this equation means that this equation has at least one root in the open interval 0, 1. We must to check if this function fx is continuous on the closed interval AB. That means continuous on the closed interval 0, 1. And if fa and fb times to each other if the reason less than 0. So that means we want to check that. We want to check that if f is continuous on closed interval 0, 1, and we must check that if f0 and f1 times to each other is less than 0. We must check two conditions. Now we will check. First, we will erase the theorem to get some space to write. Now consider first. We want to have f is a continuous on, and you say that of course fx equals the square root of, the cubic root of x minus the squared minus 2x plus 1 is continuous on the closed interval 0, 1. Because you can say that fx is the sum of power function. Is the sum of power functions, and the power functions has the properties that when they are defined at x frequency, they will continuous at x frequency. You can see that. And of course, these functions are defined on the closed interval 0, 1. So this function is defined at the closed interval 0, 1. So they will be defined. So they will continuous on 0, 1. And each of these functions is continuous on the closed interval 0, 1. Of course, these sums will continuous on the closed interval 0, 1. So we have that fx is continuous on the closed interval 0, 1. Okay. And next, we will compute f0. F0. Substitute 0 to x, we have f0 equals 1. And we compute f1. Substitute 1 to x, we have the cubic root of 1 minus 2 plus 1. So f1 is minus 1. So we have that f0 times by f1 gives the reason -1 less than 0. So these two conditions are satisfied, and of course, according to the root location theorem, we will have the conclusion that the equation fx equals 0. Of course, this is our equation, has at least one root on the open interval 0, 1. Okay. Now we will consider a similar example. Section B proves that this equation is has at least one root on the open interval 1, 2. Solution. Similar to the example A. In this example, we will give a briefly solution. Okay. First, we will change our equation to the form fx equals 0. And we let the left side of this equation be fx. And now, to prove that this equation has at least one root on the open interval 1, 2, we have to check that if fx is continuous on the closed interval 1, 2, and we have to check that if f1 times by f2 gives the reason less than 1. Less than 0. Is the negative reason. First, we have fx equals 1 over x plus 1 minus x squared plus x plus 1 is of course continuous. Obviously continuous on the closed interval 1, 2. I will give more detail about this. First, you have the function fs in the sum of the function 1 over x plus 1 minus x minus x squared x and 1. You can see that this function minus x squared x and 1 is a power function, and the power function has a property that whenever they are defined, they will be continuous. So of course, these functions are defined on the closed interval 0, 1, closed interval 1, 2. So they are continuous on this closed interval. And as to the function 1 over x plus 1, we have the similar things. This fraction 1 over x plus 1 is continuous whenever it's defined. And of course, on the closed interval 1, 2, this function 1 over x plus 1, this fraction is continuous. This fraction is defined, so it is continuous. And fx is the sum of this function. This function is continuous in 1, 2. So fx, which is the sums of the function, of course continuous on the closed interval 1, 2. And next, we want to check that the product of f1 and f2 is negative. So we compute f1, substitute 1 here. We have that f1 is 1 over 2 minus 1 plus 1 plus 1, and then we have the reason 3 over 2. Okay, and we compute f2. We have the substitute x, substitute 2 to x. In the expression we have 1 over 3 minus 4 plus 2 plus 1, and we have the reason minus 2 over 3. So of course you can see that the product of f1 and f2 is negative. And with these two conditions, with these two conditions, we by the root location theorem, you can conclude that the function f(x) equals 0 has at least one root on the open interval 1, 2. Our video about the location root theorem is stopped here. Thank you for watching. If you have any question, please comment below the video. I will answer.